Okay, example 4 is telling us that the sine of negative x is equal to negative 1/3. And anytime you see a negative angle, that should trigger you to think of even odd identities. So on our trig hexagon, if you recall the shortcut that we talked about during the lab, that secant is the only one whose abbreviation has an E in it. That means that is an even function, right? So secant is even. And its reciprocal then is also even. So cosine is an even function. Even functions, we know from earlier in the year that if you have a negative argument of your function, then that's equivalent to the positive. So for example, when you square something, right? X squared is an even function because when you put in a negative, like a -2 quantity squared, that becomes a positive because a negative times a negative is a positive. So that's our definition for an even function. Okay, that's cosine and secant. All of the others then are odd functions. So sine is odd, tangent is odd, cotangent is odd, and cosecant is odd. And odd functions, they have rotational symmetry about the origin. Their property is that f of negative x is equal to negative f of x. So when you evaluate the function with a negative argument, you get back the opposite of that function. So since sine is the one that we're given, sine of negative x is negative 1/3, and sine is an odd function, we're going to apply this rule for odd functions, which means we're going to make this a negative sine then. So sine, we'll just write our identity over here for reference. So sine of negative x is equal to negative sine of x, right? That's our odd identity for the sine function. So when we apply that here, we're going to have the sine of x is equal to the opposite of 1/3, a negative 1/3. So the sine of x, a negative and a negative make a positive, and that means that we can put a 1/3 here on our hexagon for sine. Then the reciprocal of sine is cosecant, and the reciprocal of 1/3 is 3. Okay, now we've got 2 of the 6. Then our second piece of information that we're given says that the tangent of x is equal to negative √2/4. So we'll go ahead and put that on the hexagon, negative square root of 2/4 for tangent. And so to get the cotangent, we'll take the reciprocal of that. So we'll have a -4 over the square root of 2, rationalize the denominator, and that's a -4 square root of 2/2, which reduces to -2 square root of 2. And that would be the cotangent, -2 square root of 2. Okay, now we can use a product or a quotient identity to find cosine. So if we do the product identity, we would have cosine of x equals the 2 vertices to the left and the right. So that would be the sine of x times the cotangent of x. Sine of x is 1/3, and that gets multiplied times cotangent, which is -2 square root of 2. And so we'll have a -2 square root of 2/3. -2 square root of 2/3. That's the cosine. Okay, we could use the reciprocal identity to get from cosine to secant, or why don't we go ahead and do another product. So if we use tangent times cosecant, that'll give us secant. So secant of x is equal to tangent of x times cosecant of x. Tangent is negative square root of 2/4. Cosecant is 3, and that leaves us with a -3 square root of 2/4. So negative 3 square root of 2 over 4 is the last one, and we've completed all 6 of the trig functions.